Give them a great big hand. On the way in, I hope you noticed our merchandise table and our snack table. Please feel free to help yourself and check things out. Support Geauga Parks any way you can. Support Geauga Parks with support for conservation. Before we get started, I want to give you just a little bit of background on Protect Geauga Parks. We are a large and group of reasonable people who understand that the intrinsic value of our parks, our county parks, are in the natural systems that they support and the love of nature which they foster. Our parks were created specifically to preserve and protect natural areas, that are disappearing natural areas. And conservation of these natural areas is vital to the health and well-being of everyone in the community. Our parks are treasures, a legacy to leave behind to our children, grandchildren, and to the future. We believe that one set of common sense standards should be used when making decisions about how parkland or activities are going to happen in our parks. And all changes and additions should be done with careful consideration and complete transparency by a thoughtful and committed board. Unfortunately, that has not happened in the last couple of years, and that's why Protect Geauga Parks is here. Our conservation conversations, thank you. Our conservation conversations are one way that we hope to engage the public so that they understand that conservation is a local and a global issue. Tonight we are honored to hear the presentation from the Integrated Science class of Hershey, Montessori on a top conservation topic, climate change. We are very happy to hear what they have to say. This is their future. Thank you very much and welcome to all of our panelists.
Thank all of you for coming to see my classmates and I present to you guys. It means a lot to us. And I just want to give you a little note about our presentation. Each of us is going to be presenting about a different topic related to climate change. And please write down your questions if you have any for each individual, but we're going to save all of the questions until the end of all of us have presented. And please hold your applause until the end, just so that we can just flow through all of our presentations nicely. So before we get started, I just want to tell you a little bit about Montessori education and a little bit about our school in particular, just so you know a little bit about us before we get into climate change. So what is Montessori? Montessori is an education philosophy founded by Maria Montessori. She was the first female doctor in Italy at the time of her life, and so she had a medical background, and she did a lot of observations of children, and she developed this form of education that was to foster the child's brain and make sure that the environment that they were learning in was specifically for their plane of development. And it really worked, and it's proven, and so we have a Montessori school here in Geauga County. And there's a large emphasis on community, how to work all together, and there's emphasis on how do you care for yourself, how do you care for the others around you, and how do you care for your environment. And I think that that really plays into us caring about issues like climate change and caring about our environment, so that all kind of carries over from the education groups that we have. So a little bit about our school in particular. Hershey Montessori has two campuses. We have a Concord campus, and that is in Concord, Ohio. And that has children from ages of 0 to 12. And so we have a parent-infant program where parents come in with their infants and they learn about how their child is developing and those kinds of things. Then we have a young child community, which is for children 1 to 3. And it's just, they get to kind of to know what school is like, and they're learning about different things and just fostering their brains. And then we have kind of we call it Children's House, which is kind of like a kindergarten program for children 3 to 5. And then grades 1st through 6th are on that campus. Then out here in Geauga County in Huntsburg, we have our farm campus, which has our middle school, which is grades 7 through 9. And The farm is a way for us to connect to our education. We have pigs, cows, chickens, goats. We have a really large garden and a CSA program, and we have a pond. And all of our studies are related to something on the farm to make it meaningful to our students. And we just opened our upper school program this year. So myself and my classmates that are presenting to you, we are the first class of our upper school. So it's a very exciting year for us at Hershey Montessori. Thank you.
Hi, I'm Kara Hilton, and I'm going to talk to you guys about our project in integrated science this year. So for this trimester's project, our 6-week science project has been on climate change. In our first week, we had a speaker come in and talk to us, Dr. Jeff Corney, about climate change and how it's affecting this area and what role it has played in what has been changing in not only this county and the state, but also the northern United States. So we also took some field trips when we went on our class trip to Denver. First, we went on a hike in the Rocky Mountains down to Cub Lake, and we really wanted to see how climate change is being affecting that area because it is a huge environmental part of the United States and a really beautiful place. Then we went to Greenpeace to see what they had been doing on climate change, what some of their views were, and what actions they had been taking to change it. And then we went to NREL, National Renewable Energy Laboratory, and our speaker talked to us about renewable energy and what advances it has been making, the future of it, what's happening at the moment, and how it is changing the path that we're going down for climate change. Other integrated science projects that we have had this year have been assessing our local resources. So we were looking at what our biggest resources were here in Geauga, here in Ohio, and then in the United States. And we also looked at energy demands and options, and that kind of led into this project.
Hi, my name is Adam Estrella, and my topic for this third trimester was causes of global climate change. So currently, we face a large problem, which is global climate change, and scientists believe that our production of carbon dioxide and other greenhouse gases have been having a massive effect on our atmosphere and human life. Carbon dioxide is the primary source contributing to greenhouse gases. CO2 is absorbed and emitted naturally in the carbon cycle through plant and animal respiration and volcanic eruptions and ocean and atmosphere exchange. Human activities such as burning fossil fuels and changes in land use are producing large amounts of CO2, causing concentrations in the atmosphere to rise. Recent climate change cannot be explained only by natural causes. Research indicates that natural causes do not explain most of their warming activities. Rather, it's extremely likely that humans are affecting this. So the carbon cycle is when carbon dioxide enters the atmosphere, and it happens from people breathing and stuff being burned. And carbon dioxide is absorbed by producers making carbohydrates in photosynthesis. These producers put off oxygen and animals feed on the plants, thus passing carbon compounds along the food chain. Most of the carbon animals consume, however, is exhaled in carbon dioxide through respiration. Animals and plants eventually die, and the dead organisms are eaten by decomposers on the ground. And the carbon that was in their bodies is returned to the atmosphere as carbon dioxide. In some circumstances, the process of decomposition is prevented. Decomposition of plants and animals may be available as fossil fuel in the future. So there are many harming things coming from climate change, and the U.S. is producing 18.65 tons of CO2. And the world average is 5.09, so we are way above the current average, and we need to reduce that. And 3 other countries, Japan, Japan, Russia, Canada, and Australia are only at 13.66, and that is 4 countries versus just the United States. Okay. There are many things from climate change that should not be happening, and one of the biggest problems is rising sea level. This can result in flooding in low coastal cities such as Egypt, the Netherlands, and Bangladesh. Some countries may even be completely covered in water. Another problem faced by climate change is weather patterns. Many areas in the world are experiencing floods, hurricanes, and other things in weather that are becoming much more dangerous because Hurricane Sandy and other hurricanes more recently are becoming a lot more aggressive than they used to be. And the third problem associated with climate change is the effect on animals. The fish population will be affected along with some insects, and disease will become much more common. So climate change is something we need to change, and we can't really avoid it right now. So we need to make the change right now. Thank you.
Hello, I'm Dylan Flater, and I will be talking about greenhouse gases, their sources, and their impact. So, the greenhouse effect is a natural cycle that causes the temperature of the Earth to fluctuate over millions of years. We can see this in the Ice Age between different ice ages, and there are warm periods between those ice ages. The temperature fluctuates over these years, and that depends on the volume of greenhouse gases in the atmosphere. More greenhouse gases, it means warmer temperature. Less greenhouse gases means colder temperature. What happens with the greenhouse effect is that the solar radiation from the sun comes in and reflects off the surface of the Earth, warming it a bit. Most of it bounces off into space, but some of it is re-reflected back down to Earth by these greenhouse gases. As I said, this is a natural cycle. That side of the picture is what it should look like, but this side of the picture is what it actually looks like. So we are enhancing it. So currently the most concerning gases are carbon dioxide, nitrous oxide, and methane. And the next most concerning gases are carbon monoxide, tetrafluoromethane, hexafluoroethane, and sulfur hexafluoride. So, carbon dioxide is by far the most prevalent in the atmosphere, and it is caused by burning coal and fossil fuels, by volcanic eruptions, and also the standard respirations of humans and animals. Nitrous oxide, or laughing gas, is used in medical procedures as well as a petroleum enhancement, and it is 300 times more reflective than carbon dioxide. Methane is produced mainly by livestock and agricultural and industrial factories, and it is 30 times more reflective than carbon dioxide. Carbon monoxide is produced by any kind of open flame or fire, and it is lethal to humans. Tetrafluoromethane is a commercial refrigerant and is 6,500 times more reflective than carbon dioxide. Hexafluoroethane is used as an etchant, meaning it is used for etching designs into various pieces of metal, and it has an atmospheric life of 500 to 10,000 years. And last but not least, we have sulfur hexafluoride, which is used in electrical components such as circuit breakers, and is 23,900 times more reflective than carbon dioxide. So here we have a couple of charts. This first chart shows how much of each gas is currently in the atmosphere. This chart is in parts per billion, which is the number of units of mass per 1 billion units of total mass. So for every 1 billion units of total mass, there are 1 billion, or X of those units are one gas, Y amount of those units are another gas, Z is a third, and so on. So carbon dioxide over here, for every 1 billion parts of total mass, there are 400,000 parts of carbon dioxide. Now over here, methane, 1,800. So that is a huge gap. And the rest of these are smaller than 1,800, and the final three are actually less than 1 part per billion units of total mass. So you can see that carbon dioxide easily dominates this first chart, but abundance is not the only factor when it comes to which gas is in fact the greatest threat to the atmosphere. So global warming potential measures how damaging each gas is in the environment by comparing each gas's reflectivity to that of carbon dioxide. So carbon dioxide reflects so much, but the same amount of another gas reflects this many times more than carbon dioxide. That's global warming potential. Sulfur hexafluoride, which was way over here on the first chart, as we said earlier, is 23,900 times more reflective than carbon dioxide. So it has a GWP score of 23,900. Whereas carbon dioxide has a score of 1, since it is what we are comparing everything to. So we have now the abundance and we have the damaging potential, but we need to kind of get those into one to see which is the biggest threat. And by multiplying the results of the parts per billion chart times the global warming potential for each gas, we can find the importance or the threat size of each gas. Carbon dioxide maintains the lead with 400,000, and sulfur hexafluoride brings up the rear with 2.39. Because though it was 23,900 on the other chart, on the previous chart it was 0.004, so multiplying those together gets it to 2.39. That was unexpected at first, but after doing the multiplication, it made sense. So it's clear that CO2 is by far the biggest concern, and even though the other gases are they're damaging, very damaging, they luckily are uncommon, very uncommon in the atmosphere, and so focus is, as it should be, on negating carbon dioxide. And it's frankly, it's comforting to know that we are sort of attacking on the right front, for lack of a better term. But as I said in the beginning, with the greenhouse effect being natural, change is normal, change is not the issue. Rapid change is the issue, because rapid change leaves no room for adaptation and evolution.
Okay, hello again. I'm going to be talking about temperature, so the warming and global warming per se. So, is it really getting warmer? Hopefully you guys all know the answer is yes. And most people are familiar with the term global warming, and I think that the warming of the atmosphere is kind of the most famous side effect of this greenhouse gas effect. And I think that what we kind of point this problem is kind of shifted from global warming to climate change, because there's a lot more that's happening than just the temperature rising. And my peers are going to be talking a lot about that. But I'm going to talk a little bit just about the temperature increase. So how much has it warmed? 2001 to 2010 was the hottest decade since 1880 to 1890. And 1880 to 1890 was the first decade that people on this planet took accurate enough weather measurements for us to be able to calculate a world temperature average. So the rate of change is really the issue. The temperature has fluctuated on our planet a lot throughout its history, but NASA says that historically it took the Earth 5,000 years to raise 5 degrees Celsius. And we're at about 20 times that rate. So that's really the problem. And scientists have projected that we are going to increase the temperature of the Earth with all of our carbon emissions to 1.8 to 4 Celsius, which is 3.4 to 7.2 Fahrenheit worldwide by 2100. So that is in a very short amount of time, so you can kind of gauge that really rapid change that's happening. So I'm going to show you a few maps. So our first map is showing the rate of temperature change from 1901 to 2014. And for those of you who might not be able to see what this chart says down here, so the dark blue is negative 3.5 degrees Fahrenheit, and the dark red is 3.5 Fahrenheit positive. So you can see that the greatest increases have been in areas like Southern California, near Los Angeles, and we have already seen side effects of this increase in temperature. You've heard about the really intense droughts that California has been experiencing. They've had to cut back on a lot of their water use. But surprising to me, places like Alaska and northern Minnesota, which we usually would think of as very cold climates, have experienced a lot of warming. And places like the south here, which we usually think of as very warm, have received the least amount of increase. So I thought that data was very interesting, and I had never really considered that those areas would be affected the way that they have been. So our next chart is showing us the projected change in temperature from a period of 2041 to 2070. So this is before the end of the century, before those first projections would even kick in. So this is really soon. And our chart here is a little bit easier to see. So light yellow is 3.5 degrees increase in average temperature in Fahrenheit, and we're up to 6 here in the dark red. So as you see here in Ohio, we're at about 4 to 4.5 increase depending on what region we're in. And compared to some of the other areas, we're doing a lot better, but that's still a really dramatic increase in temperature in such a short amount of time. And places here like northern Michigan and up in Canada, they're seeing up into the 5 to 6 range degree changes. So this map is showing us, it's the same source and the same time frame, and this is showing us the number of days over 90 degrees, the change in those days. So this was helpful for me to kind of see what is that temperature change actually going to look like on that average temperature change. What's that going to feel like? So this is showing us days over 90 degrees, and this is a dramatic difference because the places that were very red before are now in that light yellow. So they're seeing only a 0 to 10 change in the days over 90 degrees. But places like southern Illinois and southern Indiana are experiencing very high increases in the amount of days that they are going to see over 90 degrees. So my peers now are going to talk a little bit about the effects on wildlife and human life now that these intense changes will have.
Hello, I'm Alana Rosenthal, and I looked at the impact that climate change is having on animals. All animals except for birds. That's going to be later. Okay, so animals live in certain areas for a reason. That area that they're living in can support them and they can thrive. And if they don't have those climate conditions that they're used to and that they need, then they're going to have to move to somewhere that can support them. So unless there is a huge change or there's some kind of natural or unnatural disaster, then they're going to be staying there. So some of the major changes that can happen that will push animals out of their home would be floods, droughts, storms, and some precipitation. Most of that's all due to storms, and the storms that we're having now are more frequent, and they are more dangerous and more powerful. So any 100-year storms that we used to be having, they're now 10-year storms. So it's making a big difference. So the floods, obviously there's a huge excess amount of water that's happening, and that can trap animals and that can kill them right there, or it can affect the plant life, which the animals use to So if there's a slight sea level rise of only 50 centimeters, then they can't go to those beaches anymore, and then that drops the number down of sea turtles, and then before you know it, sea turtles are gone. Yeah. Next is droughts, and droughts is the opposite, whereas if there is a lack of water, and so there's no drinking water, and then again it's hurting the plant life, and animals don't have food to eat. So with rising temperatures, animals seek out areas that are cooler, such as mountain ranges, or they are moving in the northern or southern direction in latitude. The only problem with moving towards the mountains is that that causes more complications than it does good. For example, a pika will move up into the Rocky Mountain, and as they go higher up to escape the rising temperatures, they are going up higher in altitude, and then they can't survive because there either isn't enough food, or there's enough places for them to live, or their bodies just can't handle the altitude change. So, if a group of animals does decide to move, or that the area that they're living in is no longer sustaining them, or they just can't survive because of these disasters, then they are going to move to a new area that they can survive in, but with that there's like some unforeseen difficulties. The environment is totally different from where they're used to. So that in itself is problematic. There are probably new predators that these animals have never seen before, so that can drop their numbers down. There are new plants that they have never seen, so if they eat something that they're not supposed to, then that can be detrimental to their numbers as well. And those things, along with some others, can cause stress on the animals, and this stress on animals can cause death because they're not used to moving around as much as they are now. So if they're moving, and the stress causing their numbers to decline, then it takes forever for them to move from one place to another because the stress is killing the older generations of animals. So then they have to stop, regroup, reproduce. They have to make sure they're young, they're basics, and then they can move forward only for the process to repeat itself. And really the only thing that's going to change is if we humans decide that we need to change this. And if we don't, then 25% of all plant and animal life will most likely be extinct in the next 100 years.
Hi, I'm Sarah Donner, and I study the impact of birds and climate change. So for most of the talk, I'm going to talk about North American birds, and here's just a slide on kind of international statistics. There are about 9,787 known species of birds, 21% of which are part of extinction. If global warming exceeds 2 degrees Celsius, bird extinction rates could be as high as 38% in Europe and 72% in northeastern Australia. Different specific groups of birds are at higher risk from the impact of global climate change than others, and these high-risk groups are migratory, mountain, island, wetland, Arctic, Antarctic, and seabirds. So currently, 314 species out of 914 North American birds are classified as severely threatened by global warming. Out of these 314, 126 are classified as climate endangered and are predicted to lose 50% of their current range by 2050. The other 180 species are classified as climate threatened and expected to lose 50% of their range by 2080. So this is the wood duck range, and as you can see, the summer range is moving south, winter range is staying mostly the same, moving more into the center. Then we have the mallard duck range, which again moves dramatically between 2020 and 2080 south up into Canada as it gets warmer down in the north as it gets warmer down in the south. The horned grebe, it loses a lot of its summer range, but its winter range kind of stays the same, but then again moves north. The Baltimore oriole winter range stays the same, but moves more into Canada as it gets warmer down south. These are all from the Audubon report that was, I think, in November 2015. So one major influence to climate change, changing climate, is that birds are migrating earlier in the spring in conjunction with warming spring temperatures. Bird behavior and their environment are becoming out of sync and their ecological communities are disrupted. The timing of migration is being impacted by climate change, and some species of